So we're going to start with a circle. Let's make it about 4 units tall. Then let's stack 2 circles inside of it and color those 2 circles red. Then this region right here, let's color that blue. And I want to know what is the area of this blue region. The way we're going to calculate that is we're going to take the larger circle, subtract the red circles, and that's going to give us these 2 areas here. And then we're going to divide by 2, and that would give us the area of just the blue one. And this is how we're going to find it. So we need the area of the large circle. We're going to call that pi r squared. I'm going to make it a capital R to represent the larger radius of the bigger circle. Next, we're going to subtract these 2 circles. There'll be 2 pi r squared. I'm going to use the lowercase r to represent the radius of the smaller circle. And then we're going to divide all that by 2, and that will give us the area of this blue shape. Now, what is the capital R? Well, that's the radius of the larger circle. Since the diameter here is 4, the larger radius is going to be 2. So we'll say capital R equals 2. And then the smaller radius, the radius of these red circles is exactly 1/4. You can see there's 4 radii in this 4. So that means each of them are going to be 1. So we'll say lowercase r equals 1. So this capital R will plug in a 2. 2 squared is 4, and we can switch these to be 4 pi. And then for this lowercase r, we're going to plug in a 1. 1 squared is 1, and 2 times 1 is just 2. These 2 circles are equal to 2 pi. That means that each of these circles has an area of exactly pi. That's pretty cool. And then 4 pi minus 2 pi is just 2 pi, and 2 pi divided by 2 is pi. So this figure also has an area of pi. And then we also know the white one matches it, so it has a period of pi as well. So all 4 of these have an area of exactly pi units squared. Pretty cool. And so now we know the area of the larger circle is 4 pi, because we just add up these 4 pi's. And the circumference of this larger circle is 2 pi r, where it's the capital R, because it's the bigger radius. So we'll plug in 2 for that. And 2 times 2 is 4. So the area and the circumference of our larger circle are numerically the same. The area is in units squared, and the circumference is just in units, but they're still numerically the same. So let's look at our blue shape again. We know the area is pi, but let's talk about the perimeter. We have this green part of the perimeter on the outside here, and we have this orange double loop on the inside. Which one do you think is longer? This green one right here is the same thing as this up here, which we know is half the circumference of the larger circle. So the larger circle is 2 pi r, and then we can just divide that by 2. And this first curve of the orange line is exactly 1/2 of one of these red circles. So the 2 of them would end up making one whole red circle. So we can just call that 2 pi little r. And we can bring this orange piece up here, and you can see that it makes one of those circles. Capital R, once again, is 2. Little r is 1. These 2's can cancel, which just gives us 2 pi, and this 1 can go away. Both this green line and this orange line have the same length. And since they're both 2 pi, that means that this perimeter of the entire figure is exactly 4 pi. And that is the exact same thing as the circumference of our larger circle. They're both equal to 4 pi. So the perimeter of this is the same as the perimeter of the large circle. Is that pretty cool? And I'll talk to you guys soon. Bye.